Can you see my screen, everyone?
Yes, I can see.
Okay, that's good. Okay, let me monitor the window if you have questions. Hello, everyone. Today, we're going to show you and give you the guidelines for the ME142 final project.
Full screen, please.
Okay. The main idea is that you can develop from scratch a digital twin. In this case, for a Mechatronics system, using all the simulation and computational tools that we learned through all this semester in the Mechatronics lab, in addition to 2 new tools that we are going to learn next week. Let's going to discuss the project structure, the deliverables and deadlines for the project, and at the end, a Q&A section. All right, for the Mechatronics final project, the learning outcomes will be understanding the concept of DT and its use for Mechatronics system development and analysis. How can we improve the design of Mechatronics systems with the help of digital twin, and also making ready for being more smart in the future. Apply the MAD methodology with the digital twin for the development of Mechatronics systems, using a methodological framework for DT applications and its deploy, and mastering MATLAB Simulink through the development of a web interactive digital twin application using MATLAB WebApp server and app design and MATLAB app designer. Those web app server and app designer are the new tools that we're going to learn during the final project. Okay, so I guess this slide we saw before at the beginning of the ME142 lab. I hope right now it makes more sense in multiple senses in terms of MATLAB and Simulink. The main goal of this final project is develop a web application with online interaction for a specific Mechatronics system that allows system modeling, simulation, controller design, and validation. This is a short video from an example application. As you can see, the application GUI interface was developed using the MATLAB app designer, but all the application is running directly from a web browser, in this case, Google Chrome. This is a really simple system, a spring damper one. This is like an open loop representation of this system. We have the parameters like the mass, stiffness, damping, equilibrium, position. And we can see here as we change the parameters as well as the input of the system, we can have a step input, ramp input, or this gate input is a special type one. This is more like an impulse. We have an input force in this case that could change from system to system. This case is a spring damper system, so it's force, and our output variables will be the velocity and acceleration. Okay, let me play back again. I want to show you something. You can see here the position, the velocity, the input value of the signal, in this case a step signal starting at 0. Everything is running directly from the web browser. Everything behind this simulation is using MATLAB Simulink, and the GUI was developed with the web app designer. So everything that we learn up to now will help us to reach this point. So considering that this is what we want to reach, we need to follow some steps in order to develop the final digital twin application, also following the proposed methodology. So, okay, so let's continue with the description. Let me share again. Okay, we are going to divide this project in some steps. The first step is you are going to make groups between 5 and 6 people. And each group is going to choose a group leader in this case. And all of you among the group, you are going to choose one of these 10 applications for develop its digital twin. If you check the link, you will find all the information related to the Simulink or the block diagrams required for its simulation. For example, some of them are the well-known CTMS website. And other ones are in this new CDS Newcastle website. All the block diagram and the equations for each system are provided in each of these links. That's something important. All the modeling part will be covered here. So you make the groups and you are going to choose one of those systems. Of course, the idea is that each group develop a different application. At the end, we are going to explain how we are going to assign how we are going to assign the topics from the groups. Some of the systems we already know, like the suspension or the ball and beam. Many of these systems fit into the first and second order system theory that we already covered on the lab and also in the class. For example, this one, roller mill with Smith predictor, just like we see today in the class. So all these applications has all the modeling part for you, so that will help you a lot. You have to understand the models, but you already have in order to make a straightforward implementation. So first task, you are going to choose, make your groups and choose one of the applications. You have the links. All those links will be available on the, these slides will be available on the CAT courses once this presentation finishes. Okay, we have all those different systems. Once you choose your application, this is quite similar what we do on the last lab on digital twin and closed loop control. We choose, in that case, the DC motor for velocity control. You are going to choose one of those systems for suspension or any other of the controllers. Based on that model, you are going to develop the digital twin following the methodological framework that we explained during this digital twin laboratory this week. You have to follow all the steps. First step, step 1 and 2, you have to collect all the information for the system. In this case, which components, which sensors, which actuators are involved on each system. Also, you have to get all the documentation, modelings, transfer functions, state space, or simscape models according to the system that you have. You have to gather all that information that fulfill the first part. The next step will be that you perform the multi-domain simulation, in this case using MATLAB Simulink. That's like the most straightforward way to do it. MATLAB Simulink Simscape, that's the main idea, combine all of them. Your multi-domain simulation should simulate your system in 2 scenarios, open loop and closed loop. It's important to notice the difference between both behaviors. So the open loop system will be like to analyze the natural response of the system, and the closed loop will use only a PID controller. I know that in some cases, like CTMS, we can find lead and lag controllers. However, for this application, you are going to focus on the most common and general controller on industry, that is the PID controller. So you choose the application, get all the information, and develop the multi-domain simulation using all the tools that we already know during the semester for open loop and closed loop system. In this case, the fourth step is the behavioral matching. Considering that all these systems are into the level 1 of digital twin or pre-digital twins, we are not going to perform behavioral matching in this case for this project. However, if we jump into more complex or real applications, of course, we will need to go directly through all this behavioral matching as we do in the lab. So that's That's the first part of the final project. Choose the application and start following the methodological framework. However, the most important part or the core of this project is on the deployment of the digital twin. I mean, the final step. Up to this point, if you follow the tutorials and you made all the previous lab assignments, you will be able to reach this point. However, one of the most important things of digital twin is that can be available online for interaction and also allow the controller designer and engineers to understand how the system works and also have some start to thinking in that we are not just in an isolated environment. We have to be on an interconnected network. So in that sense, this remote access or to the application will be crucial to towards the future of digital twin applications. In that sense, the first part for the validation and deployment will be the development of all the user graphical interface. In this case, through a GUI like this, as we saw in the video. The main idea is that you can access your Simulink block diagrams, and directly from that GUI, you can access to the Simulink and replicate the simulations without the need of opening Simulink. Just you open your app and you will be able to simulate, and run all the analysis that you need. In this case, the GUI controllers will be really specific for our purposes. First of all, according to your system will have some parameters. For example, this is the example of the DC motor, the armature resistance, inductance, EMF constant, inertia, or damping. Those are the physical properties of the system. So each system on those lists will have its own list. So in that sense, you will have to introduce one section with those parameters for each system. Then you will have to provide, in this case, control. I mean, in user graphical interface, this is called control. A button or box where you can edit or change any value. You will have these edit controls here, where you can change the proportional, integral, and derivative terms of the PID controller, as well as for the parameters of the motor. Also, you will have another control to control the stop time. Another control that is required is that you can try different inputs. In this case, for example, a step input, impulse response, sinusoidal response. I guess we work all of those responses during the lab. So that's like the main idea in this case. Also, another control to select between the open loop and closed loop response. We will need some charts. Those charts should contain 3 elements in particular: the reference signal, the output or the system response, and the control action. If we are talking about the closed loop control, because those are like the main important signals in the case of control systems. Of course, you need to use the MATLAB app designer. However, during next week lab session, we are going to give you a tutorial on how to create your own GUI interface. That's like the main idea of next week lab, showing you with the study case that we have been working from since 2 labs before. I mean, the DC motor system, how you can, based on that model, create your GUI, get access to your block diagram, and make some graphs. We are going to provide you some codes that help you with this interaction. So this part will be, we will provide you support in that sense. One question before continue, you can ask directly on the message box. have you ever before worked with user graphical interface in any language, not necessarily MATLAB, but in any, I don't know, Python, C, Java, anything?
A little, yes. Yeah. No. So this is a good chance to catch up. So there's something called GUIDE, yeah, graphic user interface development environment. So you don't have to do much coding. It's actually easy to do. Okay.
All right. So I saw that some of you have some experience, others no. No worries. As Dr. Chen said, you can catch up with this GUI, with this app designer and GUI. Once you develop the interface, the next step will be deploy that interface for web development. In that case, there is a tool from MATLAB called Web App Server Toolbox. Basically, that toolbox, what does is take that GUI that you made with the app designer and compile to run in the browser. That's the main idea of this web app server. You have the tool, the GUI that you already made, and this compiles and perform the web application. The final goal for this project is you choose your application, develop the simulation, the multi-domain simulation, build the GUI for the deployment of the digital twin application, and at the end, you compile this application in MATLAB Web App Server into web language using this Web App Server Toolbox. And that, I mean, once it's compiled for web server deployment, you are going to give us, Furkan and myself, that code, and we are going to put that web application into Mesa Lab server on Castle, and you will have remote access to the server where these applications are running. The main idea is that the 10 applications will be in the same server, and you will be able to play with the application that you want. That will be the main idea of this project at the end. Start from the application, deploy the digital twin, and then make the online deployment. All right, so some deliverables. The project counts as the 20% of the final lab grade. It means that all the labs that you made up to this week are the 80% of the grade. This lab is the 20%. Considering the amount of work that we have to do right now, and that we are close to the end of the semester, we have to have some deadlines in order to ensure that at the end, all of us can have the applications working on the server. Therefore, there are like 3 deliverables at this moment. The first deliverable is the digital twin multi-physics or multi-domain simulation model running in Simulink with the app for April 16 midnight. April 16, to be precise, is in 2 weeks. The web app deliverable will be April 23 midnight. And the final report for this project will be an IEEE format, plus a 10 to 15 minutes presentation pre-recorded, and that will be May 5 midnight. That will be the final report. Some notes: the presentation should highlight the significant parts of the project. The paper should be self-contained. In that sense, if someone wants to read your report, should be able to replicate the work that you do. Okay, that's regarding to a recorder. One of you guys can make the recording for the group. Okay, those are the deadline, the outlines, like the sections for your paper: abstract, introduction, the system modeling, MATLAB Simulink model and open loop response, controller design and implementation, app designer, and web app server implementation. The challenges that you have, this section is really important because as you progress with your, as much as you progress with the development of your project, you will find a lot of challenges. In that sense, Furkan and myself will be able to answer the questions that you have on this development process. Some conclusions and future works and some references regarding to the application that you have. The length of that paper. This paper is in IEEE format, similar to all the reports that you made this whole semester, with a minimum of 6 pages and maximum 10 pages in order to make it self-contained. I know that could be many implementations details that you want to summarize on the report, but keep maximum into a 10 pages report one. Okay, so regarding to the first task, is choose a project. So after the class, make your groups, choose your partners, 5 to 6 people. Once you make your group, the group leader should submit the group members list and 2 choice of project, 1 principal and 1 alternative, no later than Sunday, April 4, 2021 midnight. It means this Sunday. By email to me and Furkan, and also via CAT courses. Something really important, the projects will be assigned first come, first served. So the first person that sent us the email, that's the person that will have the project. You have 2 choices. For example, you choose, let's go back a little bit. Let's say you choose inverted pendulum and you choose pH system. Another group choose inverted pendulum and aircraft pitch. The group that came first, the principal option will be the one that is choose. So one group will have the inverted pendulum and the other group, because was after the other group, so we'll have the alternative. That will be the idea in this case. If you want to monitor, in order to choose which project is going to be assigned, you will have access to this Google Doc. Once we receive your responses, we will update this sheet in order to tell you, in order to let you know which is the status of our current and available projects. As in the same way, we are going to add the team members. So you can see here where is the current status of the projects. Right now, I'm going to able directly from the CAT courses the assignment for the final project selection. Should be able as an assignment directly on the CAT courses. Essentially, the same instructions here in this slide are described directly on the assignment on CAT courses. So remember, projects will be assigned first come, first serve. So read the different systems, choose one of the systems and send the email. So regarding to the web app design and the app design, the web development and app designer, we will cover that topics on next week lab. But now this is your first task. Go read the different systems, and choose the one that you want to do with your 5 to 6 people group. Do you have any questions at this moment?
So don't feel worried about this final project. We are going to do a show and a tell session to walk you through from zero to finish about a sample project. We're going to record that session, okay, Aaron?
Yes, we are going to record.
You also gave us the 6-page report you put. Basically, you show them, hey, look, I got a model solution here. You just follow. Okay. If you still cannot figure out some details, we will have office hours, lab session. We'll define some office hours. Okay.
Mm-hmm. Daniel asked, we made our own groups. Yes, you made your own groups. Alfredo asked, does the groups has to be assigned in your lab session?
That's not really necessary from now on. You don't have a lab anymore. We only have that kind of demo session you can record and put on the YouTube. So no such constraints, okay?
Yes. Yes, you can. If you can make groups even if you are not in the same lab session, basically. Any other question that you have? As Dr. Chen said before, we're going to provide you a tutorial step-by-step how go from 0 to web deployment. So you will have the idea of what we expect and what you should do in order to make the project possible. Can you see the homework on the CAT courses right now? I mean, the assignment for the project selection?
Maybe you put an announcement or give this slide to everyone.
Yeah, I'm going to give this slide once. I'm going to submit the slide once the class finish. Okay, even I can. Okay, it's locked. Yeah, it's locked until 4, but you can see. But you can access the. Okay, let me open right now. I mean, it's just 4 p.m. Just like it's like a few. Okay, now it should be totally open.
Locked till 4. What's that?
I put some restriction to begin exactly after the class to be available. Be available just after the class. So that's it. It's nothing else.
Yeah. We still have about 20 people didn't show up. Like every time we got 1/3 of people not showing up. I don't know.
We can expect the video for the sample project tutorial to be posted. Yes, you will. That video will be posted. Okay. I guess we are going to provide some extra office hour if you have questions about the project. for us if you have any question about the project, or you can email me or Furkan, you know, and we can arrange office hour by demand. So that's another possibility. I mean, this week was the final lab, so from next week you will have space to work on this final project. We will be there during the lab. We'll be there during the lab to answer your questions. Yeah, we're going to be there to answer all the questions that you have. And also you can make the appointment by appointment. You can make by appointment the class. So the office hour, sorry. So that's it. Again, any other question?
For the assignment on the final project selection, when it says via CAT courses, you just mean submit like a text file with our group members list and those
Yes.
2 projects? It's just the assignment? Okay.
Yes.
And then email you as well and like CC, say Furkan onto the email?
Yes, both of us.
Okay, got it. Thank you.
It's in order to update that Google Doc as fast as we can.
Okay, so I think we are over time. Everyone, in the vaccine time, so it's available for all of you. And have a safe weekend and do something for you and yourself and others together by getting vaccinated, please. Okay. I'll get my second vaccine next Tuesday. Okay. Very good. So please do read those 3 different PowerPoints I showed you. If you only rely on my lecture, that's not enough. My lecture is just to get you the essence, the basic idea. All right. I'm pretty sure it will be easy for you to follow. And remember to watch it if you feel like you didn't get it. I'll get you this the drawing file for you, okay? I upload that one in our Week-11 directory. So everyone, take care. Have a wonderful weekend. Shall we finish here?
Yes.
Okay. Bye-bye
Yes,
then.
we're done.
Bye-bye,
Thank you so much.
bye-bye.